In this case, we're speaking again about multiplex immunoassays. So the assays include assay beads and a novel microfluidic chip. And the assay beads are paramagnetic beads that are encoded with different mixtures of fluorescent dyes to enable 20-plex multiplexing with different fluorescent signatures for each analyte of interest. And the beads are coated with a streptavidin surface that allows easy programming of the beads for specific assays. So in the case of immunoassays, biotinylated capture antibodies for targets of interest are added to the beads, and then the beads are pooled together to create a multiplex reaction mixture. The sample prep is fairly straightforward. The sample, typically 25 microliters, is added to a mixture of assay beads and incubated for a brief 30-minute incubation step. The beads are then pelleted with a magnet and washed, and then a mixture of detection antibodies is added to the beads. And in this case, the detection antibodies contain a unique DNA tag for each analyte of interest. So after the antibody mixture is added to the beads, again, a short 30-minute incubation, the beads are again washed and then ready to be loaded onto the Codetta instrument. So the beads are loaded into a unique microfluidic chip. The microfluidic chip contains an array of 250,000 wells for each sample. And the wells are about 100 femtoliter in volume and contain a unique geometry that shown in the image, where there's a round region of the well, which we call the bead region. And that bead region is sized to be able to capture a single bead. So the beads are about 3 microns in diameter. So the bead region of the well is just large enough to retain a single bead. And then there's a linear region of each well called the assay region. So the beads are loaded into the chip, and we can do fluorescence imaging to detect which beads are present in which well, as well as perform PCR in the chip and monitor the accumulation of PCR signals by fluorescence imaging of real-time PCR response by measuring the fluorescence of an intercalating dye that's present in the PCR reaction. So you see in the bottom image, fluorescence image of a subsection of the microfluidic array. You see a nice bright signal of the fluorescent beads, and you see some of those beads have what we call a tail, or the assay region that contains a PCR amplicon template is amplified, and again, the fluorescence signal is detected through an intercalating dye. And when there's a template present for PCR, the beads grow a tail. And by imaging the array and looking at the beads and the tails, the system can perform quantitative measurements.